So my name is Tim Chen. I'm the product manager for the backup recovery team. We also have Marco Calmasini from the product management team who will be presenting as well. We're doing an update for the backup recovery technologies area from OpenWorld, as well as the latest product updates we have in our portfolio. Specifically, today we'll be focusing on Recovery Appliance and the database backup cloud service. So we just concluded a very successful OpenWorld, and we had a number of sessions and activities regarding the Zero Data Loss Recovery Appliance. These will be posted at the link you'll see shortly, but we did have a number of new references and success stories that spoke on the use of their appliances. The Recovery Appliance is our engineered system for data protection. It is highly purpose-built and optimized for database backup and recovery. So we're seeing a lot of customers kind of adopt this technology. For example, FedEx is now at 22 racks of our appliances, and these racks are targeting about 3,500 databases across their estate. So we'll take a quick look at their story too in the next slide, but we're seeing a lot of good benefits for them specifically. They saved a lot on the network side from what they had before with their legacy backup infrastructure, and they also had quite a bit of space savings. With the Recovery Appliance Incremental Forever strategy, you eliminate those large, time-consuming and resource-consuming full backups, which are part of the traditional strategies, say a weekly full backup, for example. We also had Anthem present as well. These names are most likely known by you. Anthem is a large healthcare insurance provider, and they've been using Recovery Appliance for about 3 years now, and they have 5 racks protecting about 800 to 900 Exadata databases. All right, and for them, it was about cost savings and performance, and they're doing quite a bit of savings here over the last 3 years, as well as faster cloning and recovery performance as well. Because of this, they also were able to place more databases on the same rack. They're able to do more with less, okay, or with the same, if you will. Because of the backup and overhead savings, because they're just doing incrementals forever, they can do more backups now concurrently over time. We also had Eaton present on their use case. They actually submitted their own session on the business value here. And for them, they saw their 45-hour data warehouse full backup come down to about 1 hour for the incremental, and a 13-hour data warehouse restore come to a 5-hour restore window. So those are significant savings there for their backup and restore windows, right? That means their systems can come up faster. That means that their databases are protected that much quicker because the backups take that much less time. And we had other customers, Evergy, Energy Transfer, Dialog Semiconductor. For the last 2 customers, they use XSCC with Recovery Appliance, which is a growing model combination that we see here with a cloud at customer environment, and we have integrated tooling to configure backups to a on-premise Recovery Appliance. We do have a new resources page here that you see listed. This will have all the information I just presented and their details on their case studies. We have data sheets, white papers, product videos recently posted on Recovery Appliance capabilities and how that differs from traditional backup and recovery strategies. So please take a look at that as well. So just a quick snapshot of FedEx. FedEx started on this Recovery Appliance journey a few years ago, and it started with a proof of concept that was, for them, was just to verify that the functionality was in their own environment against their own databases was as advertised, right? What they found was that the Recovery Appliance actually detected anomalies in their backups to date, and they were using a third-party storage product for their backups with deduplication. And during the proof of concept, some corruptions were actually detected by Recovery Appliance, and upon further investigation, this was actually a problem with the backup itself, and was not highlighted by any of their monitoring processes. Okay, so they actually had bad backups going for quite some time for their traditional backup infrastructure. The Recovery Appliance, however, can do validation on the backup, so it does a constant check to make sure that all the files for recoverability are present, that all the database files are consistent, that all the blocks are corruption-free. And so this was a huge value point for them when they started to look into the solution. And over time, as you see, they also saw that their SAN infrastructure was just getting high contention, right? Because they have so many databases against the shared storage infrastructure here, they really couldn't sort of use hardware to work their way out of this. They couldn't just keep adding more network and more hardware. Things were just getting to a breaking point, and from a cost perspective too, the network bandwidth and for that kind of enterprise was just was untenable at some point. So looking at the Recovery Appliance, they did 13 appliances for the first round. They're about 50% completed in their migration. As I said, it was a few thousand databases now that they were targeting, and they have others that are going to roll out this year as well. So the advantages of the incremental forever with much less backup window and much less network and resource usage, as well as the space savings that they got, was tremendous. And so we're glad that they were able to share their story. Please, again, look to the website for more details on this. Also, quickly, a snapshot on Anthem. Anthem has 3 data centers spread across their enterprise, and they have an interesting configuration where they have a main East Coast data center on the left with about 650 databases, production and non-production databases, and they back up to a local Recovery Appliance cluster. It's 2 racks that are interconnected. With the interconnected racks, you get the 4 compute nodes working together. So just like with Exadata, that you can interact these together to get commensurate more performance, connectivity, storage, etc. You can do the same thing with Recovery Appliance, and so they did this so they have a single point of management, and they also can get scale out compute and storage here in their cluster. So they have a main East Coast data center, and these backups are replicated to a hub. You see in the center here, and this hub Recovery Appliance cluster is also servicing about 100 databases locally for their backups. All right, so this hub is also a 2-rack cluster, and from here, these local backups taken here all are also replicated to the East Coast center. So they actually have bidirectional replication going on, and they also have a hub and spoke. Their last data center, the Midwest data center, has about 75 databases, and these are backed up locally to a standalone RA rack, and then they are replicated to the hub as well. So here they have multiple copies of each backup. These replicated backups are managed by Recovery Appliance. Their status and monitoring and all the metrics are from a single enterprise manager console, and they're able to see kind of enterprise-wide the current data protection status, okay, of their infrastructure. I also want to highlight this very interesting use case that we have gradually seen customers grow towards using Recovery Appliance for, and that is database migration across platforms. Typically, when customers do this, traditionally it's maybe import-export or a full kind of backup in read-only and restoring that backup as read-only. So there are various trade-offs with using these techniques for migrating databases. With Recovery Appliance, we saw there was some value here in working towards a tool that could simplify platform migration for these databases at scale. All right, so utilizing all the benefits of Recovery Appliance with the incremental forever efficiencies and also restore performance by being able to restore a virtual full backup very quickly versus a traditional full backup restore and applying the incrementals. These two things kind of brought together a solution that can allow the recovery appliance to be a migration engine, if you will, for an enterprise migration activity. So a few key points here is that with this tool, which is based on transportable table space technology, you gain significant reduction in downtime. So typically it's less than 2 hours or so of downtime, and this is based on the last read-only phase that occurs when we do this final migration step. But regardless of DB size, which is the key point here, it's not a full volume, if you will, export and import kind of situation. The automation tool simplifies your migration steps. It's command line options, it's very straightforward to run, and this is good for large databases with large number of files. Okay, when you're doing transportable table space, you've got a lot of files potentially to be moved, and so doing this with a script and kind of in one shot is a great simplification and win on for the usage side. This script also supports same and cross-Indian platform migration activities. So cross-Indian is what we see a lot of these days because customers are moving to Linux or moving to Exadata Cloud Customer from their legacy IBM or other big Indian platforms. But we also support in the script same Indian migration activities, right? And there are new case studies here. These are also on that Recovery Appliance resource page before. Energy Transfer is our newest one, and they moved to XSCC using their existing on-prem Recovery Appliance for about 100 or so databases, and they are so happy with it, they wrote a paper and presented this at OpenWorld and scripted the whole thing with Ansible. So they've done a lot of automation there, and if you are interested, please take a look at their case study as well. And we also have Metro and Dialog Semiconductor from our previous conference that they presented on using this automation tool as well. There is a Moz note on how to use the tool, and so please look to this for further information on the details and how to run this procedure. Sort of a high-level flow of the migrations, so you understand how we get to minimal downtime, is we have this recovery appliance that is servicing backups, right, from all your various databases. And if you need to move a database over, the first step is to take a full backup, right? The full backup is the way we start with a backup strategy to recovery appliance, a level 0. And then following, you have your incremental backups. Okay, these incremental backups become virtual full backups on the recovery appliance. So they're full backups that can be restored, used for any purposes. In this migration use case, we do a virtual full restore across platform. Okay, and this is a new RMAN feature in 12, starting in 12, to do restore from platform. So on the destination, you execute this command. Again, the script kind of controls all this procedure and workflow to restore from platform of each of the table space data files that are to be migrated over. Okay, so you have an existing, say, Linux database that is just a shell database set up, and now you're restoring individual table spaces, and this can be done in parallel, right? Using the efficient virtual full restore and RMAN restore commands that we have. So prior to switchover, you take a final incremental and you do this table space metadata export. Okay, and this is might be familiar to you from transportable table space methodologies. We simply do a read-only just for the final incremental, and the export of the metadata is also taken. That final incremental is applied or recovered on top of those files on the destination database, and then the data pump export file is taken in on the destination as well. All right, and with that done, your table spaces can be opened in read-only to verify that the data is as expected, and then you can open that database read-write. So you've done a couple of efficiencies. You've not had to do a full level 0 to do the migration. That full level 0 was a one-time thing done a week ago, 2 weeks ago, 3 weeks ago, however long ago. And the recover was very fast because there's a virtual full restore does not actually apply, does not require incremental to be restored and applied on top of the succeeding incremental, right? We simply do a restore the virtual full out of all the needed database blocks from the recovery appliance, and you have a current full backup there available. And then the final read-only incremental is only just for the time it takes to do that last bit of change. So you can do, say, a few hours before the migration, take a final read-only incremental, and that is the time in which your source is read-only, right? And the metadata export is done as well while it's read-only, right? This is the sort of only gating time for the read-only window at this point. Okay, so moving on to another update from OpenWorld, we announced our recovery appliance X8M model, right? Similar to how Exadata now has X8M, this is also inherited from the hardware into recovery appliance. And the big change here for this model is that the system leverages a new 100 gig RDMA, which is our converged Ethernet-based technology, instead of InfiniBand, okay, which we used before for internal data transfers between compute and storage. So we're moving to a more Ethernet-based model, which is more of a standard, right, across today's data centers versus InfiniBand. So the technology has come to a point where we can now get all the advantages of RDMA now over a commodity Ethernet network layout, right? So with that said, the internal data transfer protocols are changed, and the hardware and the networking is internally different. But from the user perspective, you are still getting this the same backup and restore numbers. Our numbers haven't changed because we still use the 25 gig ingest cards, okay, in the X8 model, okay, the previous release model. So you're still going to get approximately a max of about 24 TB an hour for doing physical backup and restore kind of throughput rates. Right? We are looking at using the 100 gig card at some point for doing ingest and restores and replication, but that's still a project that's kind of under development, if you will, if you're using the 100 gig network. Our usable capacities are the same as X8. So we have here the same 155 terabyte base rack, 949 terabyte full rack, okay, specs as well. We will continue to ship the recovery appliance X8 InfiniBand models, our previous model, for customers because we know that customers use our current models and they may want to expand in their existing appliances to interconnect or continue using those that InfiniBand based protocol. So they can continue to do that. We'll still have that shipping as well. But we do believe that the X8M with the Ethernet based model is kind of the future, and will be attractive to a lot of customers looking for new deployments. Okay, so we did cover that the racks from a performance and from a capacity perspective that X8M and X8 are the same. And as I said, as we update any new performance numbers, as we get those validated by development, we'll also update that on these calls. So just a software update here for the recovery appliance. We currently ship a 19.2.1.1.1 software, and this is our 302.589.57 release. This is our interim patch release on the 19.2.1.1.1. Our releases are all cumulative releases, so any software release can be patched and used without applying the previous patches. Everything is cumulative from day one of the product, okay? So this release, our current release, supports Oracle Database 19c through version 19.4, okay, of the database. We'll have patches or PSUs released for this new release on a monthly basis as we did with our previous 12.2 release. And we'll move the 12.2.112 release, our previous release, to a quarterly patch release model until the end of next year. At that time, we plan to move that release line to maintenance mode. Our older releases, 12.2.111 and 12.1.1.18, are in maintenance mode at this point. There's no new patches that will be released for these release lines. And anything earlier than that is currently not supported. So just as you may know from your database support timelines and so forth, as new releases come out, the older ones kind of go into maintenance mode at certain points. We do have a MOS node that details this too, that we can add to this deck and share with you. But the main point here is that all customers should be actively planning for upgrade to 19.2.111. Our latest and greatest release is always the most is a recommended one. Again, this one supports DB19C, and it has all the latest changes and optimization and such for the system. Okay, at this point, I'll just transition to Marco, who will go into the database backup cloud service updates.
Okay, thank you, Tim. Hello, everyone. Let me see if I can control your screen. Otherwise, I'll have to ask you to advance the slides. So yeah, let's go into a quick update on what's gonna happen with the database backup cloud module very soon, and also a quick overview on what we did at OpenWorld. Okay, so we recently introduced a new database cloud backup module for the cloud database backup service that uses native OCI APIs. So we have a legacy module that is still there for now that uses the Swift-based interface or APIs that we used in the OCI Classic world, and that old module can be used and was used until we released this one to also to back up to OCI through an interface that OCI made available that basically emulate the old OCI Classic storage. But that has some limitations. So we released a new module that uses the OCI native APIs. So for example, we don't use username and password authentication anymore. It's now key-based. So that's stronger security, that's easier management, because with the old module being username and password authentication used, you had to rerun the installer, and so to update the wallet on all the databases if you change the password for the user, right? That's not happening anymore. Username and password are one thing that you use to authenticate to the user, to the console, but the module to access the object storage uses uses a key pair. Okay, so you set up the keys and you're ready. We also now support multiple compartments for buckets, right? When using the Swift interface or the Swift compatible endpoints in OCI, you were limited to one compartment only. Now you can create buckets in any compartment, set up authentication and permissions as you like, and we'll take care of that. Coming soon, and by soon I mean between today and Monday, we will release a new version of the OCI native module that supports object lifecycle policies for archiving. So when you set up the bucket, when you set up the module and you create a new bucket, you can define what policy, lifecycle policy you want to use, so that after a certain period of time, your data will be archived. I have more details on that in a moment. And we also changed to a more efficient way of uploading objects into the cloud storage buckets. Until now, we were using a kind of custom way of uploading multiple chunks in parallel, dividing objects or backup pieces, if you want, in multiple objects and uploading them in parallel. But those became and remained a lot of objects, right, in object storage. Now we're using multi-part upload, so basically those different objects are recombined into a single backup piece stored in the cloud bucket by the object storage. So to use this new module, you download it from the same location, the OTN page, and you're now redirected to a new site, but it's still the same. You can still use the same link that you had. You download the new module and you run it. You follow the documentation that's also obviously updated with all the details, and will be updated between today and Monday with the archiving part details. Before running this new module, you need to obtain a few information from the OCI console, like what's the tenancy OCID is, what the compartment OCID is. If you want to use compartments, this is optional, otherwise you would just use the tenancy. What the user OCID is for the user that you are using, and you have to specify what the private key file is, and you have to upload the corresponding public key to the user and obtain from the console the fingerprint and note it. Okay, so you basically go to the console, you do all these things, and you take a note of those things because you need to run them when you have to use them when you run the installer. If you are creating a new key pair, do not use a passphrase with your private key file. Otherwise, yeah, the installer would not work. This is how you run the installer. A lot of these things are the same we had before. The one with the parameters in black, like the host. Okay, you specify the endpoint. If you are familiar with the using the legacy installer for OCI, you probably remember this was Swift object storage. Right now it becomes object storage. This is the native OCI endpoint. And then you specify these rights are the new parameters that we use for the OCI native product. So the private key file, where you store the private key, the public fingerprint that you obtain from the cloud console when you upload the public key to the user you want to use. Tenancy OCID, compartment OCID, user OCID, also, right? This is all things that you can copy from the console. You specify the bucket where you want your backup to be stored. If it doesn't exist, it's created. These three are the new parameters that you use if you want to use archiving. Okay? And again, this will become active with the new installer that you can download, let's say on Monday. Okay, so you're sure you get the new one. Enable archiving by default is false. If you enable, you set it as true. You have to specify two more things. One is this archive after backup, which is how many days basically you want your objects to remain in standard object storage before being moved to archive. Okay, the default is 0 days, means archived immediately or almost immediately, less than 24 hours. Let's say I would translate it this way. Oops, sorry. Let me try to go back. Oh, sorry. Something wrong is happening. Hold on. Let me get, okay. So yeah, 0 days is less than 24 hours. Basically, then retain after restore, it's a parameter that defines for how long you want to keep your backup pieces in standard object storage after they have been restored from archive storage. Okay? And this is important just because you need to have your backup pieces in standard object storage for the time it takes for Arnon to restore your database, right? So what you don't want is have like 1 hour here, and if your actual database restore takes longer than 1 hour, the OCI object storage may archive your backup pieces, so send them back to archive storage before Arman completes. And at that point, obviously, Arman would not be able to complete the restore. The thing I didn't mention is that when backup pieces are archived, you need to restore back to standard object storage first before you can read them, and you can basically get them out of the cloud storage infrastructure. And this process takes at least 4 hours. So the advantage of keeping the data in standard object storage for a period of time, let's say, I don't know, a week, is that you know that you will be able to restore, if you need to, data old up to a week ago, immediately. You actually just go start a normal restore and then everything is fine. If data is older than a week, then it's archived. You need to get them back to standard object storage before you actually do your database restore. That obviously takes longer. But keeping data for a long time in archive storage is quite cheaper than keeping them in standard object storage. So this is the balance you have to find. Arman, I think there was one of the questions coming, is aware of the backups that are archived. What it means is that the Arman restore preview command that you can run, if you do, for example, Arman restore preview database, it will show you if there are backup pieces that are needed for that restore that are in archive storage. It will show you and list them as remote files. Okay, so the output from the restore preview will show you, okay, this is the list of archived files, and that means that you need to get them back from archive storage before you can do a normal restore, and that is done using the Arman restore preview recall. Okay, so if you do Arman restore preview database recall, it will initiate a restore from archive storage to standard storage. And when that completes, you can do your Arman restore. If you start an Arman restore right away, either with archived backup pieces or backup pieces that are still in restoring mode, but are not available in standard object storage yet, Arman would just wait. Okay, so you can also avoid doing the restore preview and restore preview recall and just do a normal restore right away. But again, if backups are archived, Arman will initiate the restore from archive storage and then wait for it to complete. When the backup status is restored in standard storage, then it will go ahead and do the actual database restore. So you have a delay, basically, right? It's probably better if you prepare that in advance. If you can, doing the restore preview recall, when everything is ready, you go ahead. The other parameters in black here, they do not change. They're the same we had before, okay? So if you specify this archiving parameter to true in the installer will attach a policy to the bucket, either the bucket it creates or an existing bucket that has no policy or a different policy. So you can also use it to change the policy on a bucket. And you will see that policy if you go to the Object Storage Cloud Console, and you select the bucket and you look at the lifecycle policy rules, and you will see that there is a policy like the one that I had in the installer before that says archived after 0 days, and it's exactly the same, archive objects after 0 days. And then there is an exclusion here that's always there. It has to be there. Basically, XML files that the Arman Cloud Backup module creates to manage the objects in object storage, those must remain always in standard object storage. They're very small, obviously, but Arman needs them to be immediately available and accessible so that it can read what backup pieces are, where they are, etc. Okay, so if you create a policy manually, either you manually add this one or add this option of exclusion for the XML file, or you will not be able to restore. If you don't exclude XML files, they get archived as well. Arman would not work. You get an error saying that there are no backup pieces. Maybe we can go. I go through a few more things that we presented at OpenWorld, and then we can open for question and answer. I think there may be a few. So this, where the things I just described, is all about OCI and the new world. So what happens if you have backups in other cloud infrastructures? Okay, so you can have backups, Arman backups in OCI Classic, again, that you used, that you created using the legacy module. You can have backups in OCI that you created using the legacy module through the Swift compatible endpoints. And you can have backups also in AWS S3, for example, that you created using the OSB cloud module for AWS S3. All these tools use the same object naming, object format and naming for the backup pieces. So you can basically back up with one module and read your backups with another one. They are compatible, okay? And this also means that if you want to migrate to OCI and use the new OCI module and take advantage of these things that I just described, you can use an external tool like rclone, for example, and copy all the content of a bucket. And again, that can be an Amazon S3 bucket, can be a container in OCI Classic. It doesn't matter. You copy all the content over to the OCI infrastructure world, and you're good to go, basically. There is no other change needed from an Arman perspective. If you have the Arman catalog and all the information about those backup pieces, after you removed them and you install the new module pointing the new bucket in OCI, you're good to go. Okay. We also created and just recently published a few days ago a migration runbook from those coming from the OCI Classic to OCI. And yeah, this is the link. You can go and read it if you're interested. There's also you can also follow basically the same process in a very similar way to migrate from AWS S3, like in this example, using rclone, which is a tool that you can download. It's free. Then you prepare your OCI target, installing the new module on your database client, and you have to do one more thing, which is go to the OCI console for object storage. I think it's an identity, and set up S3 compatible keys, because we are using the S3 compatible endpoints in OCI for rclone. I don't think our rclone has yet an OCI interface. So we're using the S3 compatible. And rclone is very simple to use. You just set up your environment variables. You can use a configuration file if you want, but you can also ignore the configuration file. That's set up environment variables. Like in this case, you set up your source. It's called S3 here. Variables. Type is S3. You specify your access key ID and your secret key ID for your source bucket in Amazon. You specify what the region is, and you specify the bucket. Okay, and similarly, you set up S3 type access variables for OCI. So you specify the access key ID and the secret access key ID that you get on the OCI console. You specify the region. You specify the endpoint where you have to use the S3 compatible endpoint, which is made in this way. Basically, it's storage namespace .compat.object storage. I mean, this is standard for everything in OCI. And you just run rclone, and it will take care of this. It copies everything over from this bucket in S3 to this bucket that you specify here in the command in OCI. And once the process completes, you can just go to your Armen and do a restore validate and make sure that everything is copied successfully. And you're good to go again. There is no cataloging operation. There is nothing else to do. Okay, so it's very easy to move things from one place to another. You can do things a little more sophisticated if you want, because you can specify filters. So if you had multiple databases backed up to the same bucket in OCI on the same container in OCI Classic, and you want to only copy one of them, you can also do that. It's a little bit more complicated. Maybe you can send me an email or reach out to us through the Ask Tom and ask a question there, and I may help you in doing that. So moving to the other topic that was also presented at OpenWorld, it's a modern exercise if you want. This is not a product, it's not a service that you get out of the box. It's a exercise, yeah, I would say. It's an example of using the OCI event service and the serverless functions to achieve one thing that sometimes was asked, okay, or two different things that can be combined together if you want. One is the ability to replicate backups to a different region. That is something that OCI object storage does not support yet. So you cannot just create a bucket in OCI and say, I want to replicate all the content in this bucket to this other bucket in another region. That's not possible yet. But sometimes we have questions like that. And the other is, how do I create a secure worm-like, so write once, read many bucket where no one has access to? So DBAs cannot delete backups from there, or malware cannot get there and change my data. This can also be used as a safe place where you store your backups if you want to protect from, malware, specifically things like ransomware that can come in and encrypt all your files and maybe including your backups, right? If you have backups running on local disk, on the same disk where your database is, and you get an infection like this, you may lose access both to your database and your backups, right? So having them in a safe place where no one can access them can be a good thing, right? And so what we did was create this, using the event service, create this serverless function that is triggered by the event service, and that copies thing to a different bucket where the DBA has no access to. And this is the example. And again, we probably don't have time to go through the details here, but obviously if you have questions, feel free to ask them later, or you can look at the OpenWorld presentation. It has more details on, a little more details on how, specifically the code that was used, part of the code that was used to create this. But basically, how this thing works. Oops, sorry, let me go back. So we created an event service rule that is filtered, so it's associated to the specific bucket that we were using in the region, and it is filtered based on two types of objects. So every time there is a create object event, okay, the rules see if this object matches one of these patterns. So all the objects stored by Armen in object storage starts either with the SPT_catalog prefix or with the file chunk prefix. Okay, SPT catalog prefix are the metadata XML files. File chunk prefix are the actual backup pieces, right? Plus there are some XML files, but they all start with it. So every time we see an object created that has a prefix that starts with SPT catalog or a file chunk, it means that it's something that we need to copy somewhere else. Okay, and in this specific exercise, we were trying to simulate the use of a monthly backup. It means that I want to have regular backup going into this bucket every day, every hour, catalog, whatever, right? It just keeps going. But I want my end of month backup only to be copied or replicated somewhere else. So what you can do with you can create a rule like this, and then when you do a backup, you specify the format and you add this monthly underscore percentage t underscore percentage u, and this means that this monthly kind of tag is used in the file chunk name in the backup piece name that becomes that chunk name. Okay? In this way, the rule is triggered, or actually the rule triggers the serverless function, which was a Python-based function that was doing only one thing. It takes the object name that was triggered by this event and copies it over to a different bucket in a different region. And this bucket has no user allowed to access it. The only user or the only object that can access this bucket is this serverless function. Okay? So no one has access to this thing. Or read and write and delete permissions if you want, right? This user only had read access. And so what we did, we ran this, we did a backup here, and then backup was replicated here. We reconfigured the Armin Cloud Backup module to point to this bucket and run an Armin validate, see that everything was okay. We also tried doing an Armin delete while the Armin Cloud module was pointing to this bucket, and then we saw that nothing was deleted, basically, right? So you could do a catalog and get all the information back. And there is a little video recording of this, so if you're interested in seeing, you can also see that. And yeah, I think that's all we could cover for today. So yeah, if you have questions, you can unmute yourself and ask questions. Otherwise, I can look at the chat here. Maybe someone were already answered by Tim or Kelly. So.
Thanks, Marco. I'm going to take over control again so I can
yeah, go ahead.
Stop this.
And Marco, this is Kelly. There's 2 questions at the very bottom of the chat that still are open.
Oh, okay. Let me go and if I can see them. Okay. Okay. Is there a do you have for serverless option for region copy? The region, I mean, in the same region, was that the question? So the example I showed was from one region to another, was from Ashburn to Phoenix. I don't know if that's a region type of question, but if it's that, yes, it's possible to copy to different regions. The thing that I think it was in the slide I forgot to mention, and maybe I clarify now. The event service is not a guaranteed service. It means that there is the chance that an event may be missed. If an event is missed, it means that a file is not an object, is not copied to the target. So it's always recommended, once you've done this, run an arm validate to make sure that everything pointing to the target bucket. So to make sure that everything has been copied successfully. Because I mean, it never happened to me, but that's how the event service is documented. They say it's not guaranteed. So yeah, do not trust it 100%. That's the point. Can this option be built into the module in future or Terraform? Yeah, I mean, yes, definitely can be built, and there's no plan for that yet, but it can. About Terraform, yeah, that Terraform can probably also be used to set everything up. The code was the serverless function code was very basic Python code that was used, as I mentioned. This was really most an example or a proof of concept if you want to see and test this, if there's something that can be done, which is. So it was a very basic Python code using OCI SDK to basically just copy the object that was passed by the function, the object that was passed to the function by the event to a different bucket in a different region, and it was hard-coded in the, but you can do all the add all the sophistication you like. Obviously, you can use multiple buckets. You can. There's no limit, obviously, to what you want to do. What you want to do. The only thing that you have to remember, as I mentioned, is validate your backups when this is done to make sure that everything is properly copied. I don't know if I answered the question, Eric. Otherwise, you can unmute yourself. And
hey, Marco, can you hear me?
Yeah.
So regarding the question about the Terraform, I know you showed the Python script. Is there something you can share with customers?
Yeah, it's again, it's a very basic example, but yes, I mean, I can definitely share. I had it in a slide at OpenWorld, but we didn't put it here to try to have a shorter version. But it's in this OpenWorld slides. So if you go there, it's not all of it. I removed the parsing, but again, it's just parsing a JSON file to get the object name and file name, etc.